Importance of pH control in seawater. Desalination pretreatment. Maintaining the pH level within a specific range in seawater desalination pretreatment is crucial for several reasons. 1. Preventing scale formation. Calcium carbonate. High pH levels can lead to the precipitation of calcium carbonate, forming scale on the reverse osmosis, RO membranes. This scale can reduce membrane permeability, leading to decreased water production and increased energy consumption. 2. Optimizing coagulation and flocculation. Coagulant effectiveness. The effectiveness of coagulants used in pretreatment to remove suspended particles and organic matter is pH dependent. Coagulants often work best within a specific pH range. Floc formation. The formation of flocks, which are essential for sedimentation and filtration, is influenced by pH. An optimal pH range promotes the formation of larger, more settleable flocks. 3. Protecting equipment. Corrosion. Extreme pH levels can cause corrosion of equipment, leading to leaks, reduced efficiency, and increased maintenance costs. Membrane integrity. Maintaining a pH within the recommended range helps protect the integrity of the RO membranes, prolonging their lifespan. 4. Preventing biological fouling. Microorganism growth. Some microorganisms thrive in specific pH environments. Controlling the pH can help prevent the growth of fouling organisms, which can clog membranes and reduce water production. 5. Ensuring product water quality. pH of treated water. The pH of the treated water can affect its taste, corrosiveness, and suitability for various applications. Maintaining a pH within a desirable range ensures that the product water meets quality standards. pH control is a critical aspect of seawater desalination pretreatment. By maintaining the pH within an optimal range, desalination plants can improve efficiency, reduce operating costs, and ensure the production of high-quality potable water.